In this lesson, we're going to do proofs with similar triangles. With triangles, when we're proving them similar, we want to use the angle-angle similarity theorem. I believe it's a postulate. Angle-angle similarity. This means that we only need to show that two angles are equal in measure in order to prove that two triangles are similar. We know if they have two angles equal, that the third angles also must be equal. And when you have three angles, you know that the triangles are similar. So let's try some proofs. Here we're given that DE and BC are parallel. That's a great statement because what that tells us when we know those two lines are equal in measure, that we can look for alternate interior angles that would be equal in measure, and we can also look for corresponding angles that would be equal in measure. We definitely want to look for angles that are equal in measure first because they're easier to work with than angles that are supplementary. So we want to look for alternate interior or corresponding angles. Let's go ahead and draw on this picture a little bit. We have these two lines are parallel, and then we have this as our transversal. Well, if we want to prove that this little triangle is parallel to that big triangle, then we want to look at angle AED here and angle ECB. Those two angles are corresponding angles, and since the lines are parallel, we know those two angles are equal in measure. We can also see that our little triangle here and our big triangle here share an angle in angle A, and we know that that must be equal to itself. Well, for angle-angle similarity, all we need is two angles equal in measure, and that proves they're similar. So we're practically there. Let's go ahead and get started. Let's draw our table, and we want to start out with the given. DE is parallel to BC. That's what we're given. Then we said because they're parallel, the measure of angle AED, let's erase some of this coloring, so we can see. I'll just get rid of it that way. Okay, there we can see a little bit better. Angle AED is equal to the measure of angle ACB because parallel lines implies that corresponding angles are equal in measure. We could have also used angle ADE and angle ABC. Those are also corresponding angles because you have the parallel lines. That would just mean AB would be your transversal instead. We also know the measure of angle A is equal to itself, measure of angle A, by the reflexive property. And then once we've proven two angles are equal in measure, we can say that the two triangles are similar. Drag that in by angle-angle similarity. Next, we're going to try to prove that triangle ABC is similar to triangle AED when we're given that DE is parallel to BC. So this side over here is parallel to this side over here. When we know we have parallel lines, we want to look for transversals. And if you notice, BE here is a transversal. And just like before, we want to look for alternate interior angles or corresponding angles because we know both of those are equal in measure. Well, with this transversal, we have this angle here that's part of triangle ABC, and it seems to be alternate interior to this angle here that's part of AED. So those two angles must be equal in measure because we know that when you have parallel lines, alternate interior angles are equal in measure. We also have a set of vertical angles. This angle here is equal to this one over here by the vertical angle theorem. Well, we know once we have two pairs of congruent angles, we know that the triangles are parallel. So let's go ahead and get started. We'll draw our diagram. We'll draw our chart. We start out with a given. DE is parallel to BC. And then we said, because those two lines are parallel, once we're just feeding off of this piece of information, that angle B must be equal to the measure of angle E, because parallel lines implies alternate interior angles are equal in measure. We also said that we know that this angle is equal to this angle over here by vertical angle theorem. But we need to be careful not to just call it angle A, because there are multiple angle A's. So we're going to say the measure of angle BAC is equal to the measure of angle EAD by the vertical angle theorem. Once we know that those two angles are equal in measure, we can go ahead and say that the two triangles are similar by angle-angle similarity theorem. That's it.